Welcome to AIRS 3. So I'm guessing that many or all of you have done AIRS 1 and 2 earlier this week, or perhaps you've done them earlier than that. AIRS 1 was all about your research question. So identifying the concepts and the themes within your area and turning that into a research question. AIRS 2 was more of a hands-on practical session about database searching, designing and creating effective search strategies. Today's session is going to be about data. Before the session today, you had been set a little bit of homework just to have a look at the AIRS module about coding the literature. We'll do a very quick recap of that in a moment. We'll also have a quick look at some bibliographic management software. We won't spend a lot of time on that. And we'll spend most of the session today looking at data and data management strategies to help you organize information proficiently, ethically, and legally. So it's all about developing your system to manage your data. So there are some recommendations, there are some tools, there are some strategies that you can use to make sure that your data is safe and protected, because your data is going to be a valuable asset to you while you're doing your research. So you want to make sure that you keep it safe. Okay, so coding the literature. So just one point of clarification, when we talk about coding in this context, we're not talking about computer coding. So we're not talking about writing any sort of script of any kind to do anything. It's just about labeling the literature. There are some other strategies that you might use. Did anybody come across the acronym LATCH during the pre-session work? Come across that one? This is something that you might also use as part of your system. So if you're using a literature grid or something like that, but another thing that you might have come across in the pre-workshop activity. So the literature grid is about a system of taking notes and so forth from your readings. But LATCH is all about, it's an acronym that stands for location, alphabet, time, category, and hierarchy. So these are some recommended attributes that you can use for your note taking. So location is about making a note about where the author sits within the debate. In other words, do they agree with your view of the material, or do they have a different point of view? So whereabouts do they sit in the continuum of opinion on your topic? So you can just make a little note about where they sit in that debate. So alphabet is quite simply making sure that if you have a list of things, just sort them alphabetically, just to help you retrieve them later. You can also organize them by time. So keep your notes in date order, because as you progress through your readings and your notes, you might have different perspectives or learn new things. So keeping them in date order might also then help you retrieve particular notes when you need them. Using categories. So this is sorting your notes by themes. So you might have themes that relate to sections within a chapter of your thesis, for example. So whatever your topic is, there would be key themes that you could use to help group your notes as well. And related to that is the hierarchy. So those categories you might even put into some kind of hierarchy. So you might have broad headings, you might have narrower headings, and you might have very specific headings and arranged in a particular hierarchy. So that's one idea that you could use to help you. With regard to the tools, we're going to have a look at some bibliographic management tools a bit later on, but there's a variety of other tools you could use as well. Okay, so just continuing on with that idea of themes. So from within your research question, there will be different aspects of your topic that you could think about as themes, and they can correspond to the codes that you develop for your note-taking. So I should also say too, the system of coding needs to be your system. It needs to be something personal that you develop and that you can understand. It does need to be coherent, logical, and quick. So you don't want to have a system with 200 different codes, because can you really keep track of 200 different codes? It has to be workable, it has to be memorable, and has to be efficient. So you'll work on that. So when you're reading the literature, you're using some reading strategies, scanning, skimming, or reading in depth. you can then apply your codes to the literature to help you identify the important themes. You might also come across some very interesting ideas while you're reading that aren't actually relevant to your research question. So, as illustrated by the image on this slide, you might even consider pinning your research question up on the wall next to your computer. So if you are reading an article that's really interesting, but if it's not going to help you answer your research question, you might want to park that reading aside and then read it at a later time when you've got some more time to give to optional reading rather than required reading. So the codes themselves can be characters, they could be numbers, they could be phrases, acronyms, any system that works for you. But as I say, it does need to be coherent and logical, and I'd suggest concise. So you may not want a large number of codes. And then how you use those codes might depend on what you're doing at the time. So if you happen to have a hard copy of a reading, you might be annotating in the margins, such as that image on the slide. If you're using some reference management software like EndNote, you can create groups to store the readings by category. And of course, if you're using a consistent code, you can see also the image on the slide. There are three groups, three EndNote groups: attrition factors, performance impact, and retention impact. That might correspond with your hard copy annotation. So P for performance impact, AF for attrition factors. So it does need to be consistent. And it might be something that you want to have a think about before you do a substantial amount of reading. So before you get too far into your reading, you might think ahead to, well, what kinds of themes will I be looking for as I go? So that doesn't mean you can't adjust it as you go, but if you start with a plan at the beginning, that will give you more consistency as you work through the readings. Okay. Here's an example research question. What do you think the main themes are within this research question? When you're reading, you might come across some articles that are about mentoring in general, so that could be some useful background reading for the topic. You might also find papers that look specifically at mentoring minority students, so you might have a different code for that particular theme. You might also be reading about mentoring university students more broadly, so you'd have another code again. And since mentoring might be one of the factors that affect student success, you might also have another theme just looking at other or all factors that contribute to student success. So you might just have something about completion of graduate degrees. So depending on your topic, that might influence how many themes that you need or would find useful. There's no particular right or wrong answer to that, but it's what works for your particular topic. We'll just take a moment to talk briefly about bibliographic management software. So I expect some of you or all of you have come across these already. So there's a variety of tools that do similar jobs, and your choice. It's your choice as to which one you use, although there are a couple of things you might consider if you haven't already decided what to do. If you haven't chosen a reference management software yet, you might first like to have a chat with your supervisor, find out what they're using. There are advantages in using the same software that your supervisor is using. If they don't have a particular preference, well, then you can also just look at the pros and cons of the different apps that are out there. EndNote is probably the most commonly used reference management software used at QUT. It's fully supported at QUT. We do run training and workshops for that. If you are interested in some training, we run these workshops all year round, every few weeks. So it won't take long before the next round of workshops are advertised. So the software allows you to find, import, export, store, organize, and use references that you find through your reading. So when you're searching the databases for literature, you can export your search results directly into your reference management software, and then you can organize them as needed. It can also help you with your referencing. So software like EndNote works together with Microsoft Word and it helps you format your references. So one thing to keep in mind is that you still need to know how to reference. So some people think that reference management software will solve all of their problems and do all of the referencing for them. Well, it can do most of the work, and it can do a lot of the boring work of formatting a reference, but you still need to check them because things can happen. When you export records from a database, there may be some errors in that data. There might be some formatting issues like all uppercase or something like that. So you need to be able to spot those issues and fix them. So you still need to know how to reference. The reference management software will also be your own personal professional library. So it's going to be a valuable resource for you. The further you go into your study, the bigger the library will become. And just like any other document, your thesis or your data, your library is going to be something that you want to keep backups of and have some sort of routine for protecting that data. In most cases too, you can store other kinds of material there as well, whether it's a PDF file, pictures or images, tables, etc. EndNote in particular, you can include other kinds of files and embed them within the records. I guess some of the disadvantages though, the more literature you collect, the bigger that library becomes. And if you are adding PDF files to that library, the file size is going to get quite large. So you need to make sure that you're storing and managing your references in a location that can cope with large files. Also too, if you're working in multiple locations, so whether on campus or at home and maybe in a research center as well or something like that, you'll need to have a strategy so that you can use your library wherever you are. And it can be done. So you just need to know how to do that before you get too far into it. One question we do often get is, how many libraries do I need? And the answer is you can have as many as you like. There are advantages in having one library for everything, because this software can help you to organize the literature. Even if you're working on multiple projects, you can still organize the literature within a single library according to each project. However, if you are working on a separate project and maybe you're collaborating with other people, in that case, you may prefer to have a separate library dedicated to that particular project. So you can have as many as you need, but there are advantages in having a single library for everything, because then it's just one library that you need to back up, one library that you can go to whenever you need something. So there is a table that we can go to. Let me just open this up and let me drag this across. So we have a page here looking at some of the main reference management software and some of the key features for them. So we've got Paperpile, EndNote, Mendeley, Zotero, and Jabref, which is related to BibTech. So you can have a look here. So if you aren't committed to a reference management app yet, and you're not sure which one to use, this table here might give you some information to help you make your decision. But also, as I mentioned earlier, talk to your supervisor as well. We're going to move away from the reference management software now and have a look more at your data. So during your research, your study, you're going to be collecting data in one form or another. So depending what discipline you're in, it might be different kinds of data. We're going to have a closer look at different data types in a moment. But we're just talking generally at the moment about the question that's in the AIRS assessment, the AIRS resource log, specifically relating to data management. So just to clarify what the requirements are, we're actually interested in your data. So it's not data in general. It's not really, we are focusing on your data. Now, a couple of points we can share with you is that whichever methodology you're using to collect your data, that is obviously relevant to describing your data. However, when it comes to completing this question in the resource log, we don't really need to know much about the methodology. So yes, if you're going to use a focus group, do tell us that you're doing a focus group, but you don't need to tell us how to run a focus group. Just tell us what kind of data you're collecting and how are you going to back it up, and so on. So we do often get responses in the assessment where people tell us about the methodology and not about their data. What we do want to read about is your data. So that includes the format and the scope. So what file types will you be using? Do you have to use proprietary software to gather that data or generate that data? How much data are you going to collect? Where might you store it? All of those issues are what we're looking for. And related to that is storage and backup. So if you go to the AIRS website, there's some information there. And in fact, I've got something on a later slide, which will talk a little bit about it as well. But there are some recommendations from our IT specialists about how to safely and securely back up your data. So I'm going to come back to this, but things like external hard drives and cloud drives like Dropbox or Google Drive, they're not recommended for long-term storage of research data. It's a legal and technical minefield using some of those systems. And of course, there's high risk with things like external hard drives that may fail or get lost or something like that. So there are some recommendations that you can have a look at to help you with your own management of your own data. Okay, so contextual information or metadata, we're going to go through this in more detail in just a moment, but this is just a way of describing your data so that it can be made sense of either by yourself later on or by someone else if you're able to share your data. And part of that relates to the principles of FAIR, and we're going to go through that in a moment. So FAIR relates to findable, accessible, interoperable, and reusable. So we're going to talk more about that in just a moment. Part D, though, is a more general question. So here you don't necessarily have to refer to your own data. This is just asking you to show us your understanding of some of the commercial, legal, or ethical considerations related to storing and sharing research data. So if you want to talk about your own data, that's fine. But if you can also just provide a more general response if you want to. And part E is just identifying how long your data is legally required to be stored. Got some more information about that coming up a little bit later. There's a schedule of minimum retention periods depending on what kind of data it is you've collected. So we'll come back to that in a moment. So here's a diagram you may have seen before. It is used around QUT to describe the data collection process. We're going to revisit this slide a little bit later on just to recap on what we haven't yet spoken about. But it's going through the cycle of planning, collecting, processing, publishing, preserving, and reusing. And you'll see in the diagram too, in the center of the image is where your data sits. So you've got your data, there's some metadata to describe it. You need to address the principles of FAIR, F-A-I-R, curation, so storage and backup, and any associated skills you might need to manage your data. So at this point, I'm just going to tell you 3 short anecdotes around data management. So these are 3 true stories. So first one relates to a research team at an Australian university. I won't name who the university is, but I can tell you it wasn't QUT, thankfully. There was a research team who wrote some computer code that they customized to analyze a particular data set. So they wrote some code to perform some sort of analysis and generate a result for them. So they did that. They wrote their paper. They submitted it to the journal. During the review process, they discovered that there was an error in the computer code that they'd written. However, the downside, though, is that nobody had saved the data. So instead of just correcting the computer code and rerunning the analysis, they had to abandon the publication. Nobody had taken responsibility for saving the data, which meant it was effectively lost. It was gone. Waste of effort for that particular project. So that didn't have a happy ending. Second anecdote, another true story. This is relating to a researcher whose name is Siegfried Bethke. And during the 70s, he was a PhD student doing some research on particle collision, I believe it was. So he did that, the project completed. He then continued, everyone continued on with their research. And in the 1990s, Siegfried thought it might be useful to go back and revisit that data and reanalyze it with the new tools that were available. So obviously computing power had improved. There are new techniques available. So he thought it would be useful to go back and look at that data and reanalyze it. The trouble was the project in the 1970s, again, nobody had taken responsibility for curating that data. So what ended up happening was there was a haphazard distribution of that data around the world. Different people had different parts of the data, but no one had a complete set. One person did have some data that they'd stored digitally, and they had the forethought or the foresight to move that data onto new formats as new formats became available. So it was relatively current. But there were also boxes of paper with computer printouts that was the only surviving format for that data, which needed to be re-entered manually into the computer. So Siegfried, it took over 2 years to locate and prepare that data for reanalysis. But the happy ending is that Siegfried's research team produced 12 high-impact papers, which were then later cited by the Nobel Prize Award Committee. So 2 years of work, which shouldn't have been required at all. Somebody should have taken responsibility for that data. But the happy ending was that he managed to pull it all together. Last anecdote, one of the primary industries departments in New South Wales for decades were very interested in kangaroo populations in rural parts of New South Wales. So for decades, they would survey kangaroo populations in different regions. One of the things they did along the way was keep track of weather patterns. So while they were counting kangaroos, they were also tracking the weather data. So that wasn't particularly what they were interested in, but obviously that has an impact on kangaroo populations. So you can probably see where I'm going with this, that they weren't collecting weather data for its own sake. They were interested in the kangaroo populations. But as things have turned out, weather data has become quite a hot topic, and that kind of historical data is in demand by a lot of people. So when you're collecting your data, if you ever think, well, no one's ever going to want to look at this again, you might be surprised. So there may be something down the track that you're not aware of yet where your data is valuable to someone. So that's why we do spend a lot of time talking about reusing data. The other thing about reusing data, just before I move off this slide, is that a lot of the funding bodies, the people who provide the money to do the research, they want to get maximum value for their money. So they're very encouraging, or in fact, many of them will mandate that researchers have to share their data once the project is finished, because they want to get maximum value. If they're paying money to collect that data, they want to make sure that maximum value is derived from that. Okay. So a couple of words about methodologies. So you may know already how you're going to collect your data. We just want to put a little plug in for a tool called Sage Research Methods Online. So if you haven't come across this one before, it's a collection of handbooks, manuals, articles, books, book chapters, all about research methods. So I'm actually going to go and open this one. And you can get a whole book about your particular methodology. If there is one, you can find it here. Or if you just have a specific question about a statistical formula or something like that, this can provide the answer for you. So if I was doing focus groups, I could just do a search for, let's just do focus group. I'll do a search for this in here. Okay, so we've got here a book called Focus Group Methodology, Principles and Practice. So there's a whole handbook there. We scroll down, looks like there's a chapter in this book about something about focus groups in schools, focus group interviews in education and psychology. So there's quite a discipline-specific handbook. I won't go through all of these, but as we go down, there's a lot of them are books or book chapters, but there's also journal articles, there's also videos, there's a variety of different formats that you could go through. There's another one called Doing Focus Groups. So if you're wanting an overview of your topic or something specific, this could be useful for you. If you're looking for a particular if you had a question about something specific, so if I do a search for chi-square, for example, a statistical method, this can give you some information and instruction about chi-square. So looks like there's a whole book there, or I beg your pardon, it's a chapter within the book by the looks. We've got another one with another chapter, the chi-square test. So if you have a specific question, you might find an answer. If you need to know more about the methodology, you might also find the answer here as well. So this is just a little promotional plug for the tool, something that you might find useful later on. Sage Research Methods Online, most people refer to it as SRMO. Okay. Another aspect you might that might be relevant to you is the use of secondary data. So again, this is coming back to reusing data. Different organisations, different researchers share their data. So an obvious one is the Australian Bureau of Statistics. The data they collect, that's shareable. So you can access a lot of it for free. Some of it you can still get for free, but you may need to register in order to use it. There may be some confidential aspect to it, some human data that you just need to acknowledge certain rules about how you use the data. There are also commercial data sets. So some of them we've got listed. We've got 3 guides that are available. These are links that you can go to find them. There's also a link at the bottom of this slide. If you come across a data set that's available for purchase that is relevant to your research, if we don't have it already, talk to your liaison librarian. It may be possible for us to obtain a copy for you. So as long as it's available, as long as it's affordable, as long as it's usable within our QUT environment, it may be possible to acquire that for you. Now we're going to come back to data again. So we spoke briefly about this earlier. So this table just illustrates some of the broad types of data, so whether it's experimental or simulation data, observational, etc. So when you look at this table, you might recognize where your data sits. So this table will help you with your response in the AIRS resource log as well. So thinking about what kind of data you're generating, how that data is created, and what kind of data it is. So is it spreadsheets, or is it images, or is it sound recordings? So whatever it happens to be. So these are the broad categories: experimental, computational, simulation, observational, derived. So derived is when you can combine different compatible data sets to create something else, something new. And reference are things like the Bureau of Statistics data. So these are existing data sets that are available for use. So another consideration for you is that I expect most of you, or if not all of you, are still working towards your stage 2, which includes a section about your data. So one of the sections asks you to indicate where you're up to with your data management planning. So there's on this slide here, you can even see a screenshot of the section where you at least have to acknowledge that it's a requirement. So the first one is that you haven't yet considered it, but you will. Or if you have progressed a bit further than that, you can indicate that in your stage 2 documentation. Just as a brief aside here, so some of you may wonder why you have to do this unit, the AIRS unit in particular. So the general answer to that is that what you learn in AIRS is what you need to do towards your stage 2 in any case. So we don't want to give you work that you don't have to do already. We're just trying to formalize it and package it in a logical way to help you, in particular, get through your stage 2 process and onto the confirmation after that. So just as an aside, AIRS 2 is all about your stage 2. We're not asking you to do anything that you don't already have to do. All right. Also here, we can see that there's a link to the Research Data Management and Primary Materials Checklist. So this gives you some information about that. I don't know if that's visible to you. It's just dmp.qut.edu.au. So this is a tool that you can use to help manage your data. And this is particularly helpful if you are working in groups, because part of the management process is to make sure that group members are aware of their roles and responsibilities, who's responsible to do different tasks in regard to the data, just to make sure that everything is covered. And of course, that particular data management planning tool is what's commonly referred to as a living document. So when you first begin, you complete as much as you can, but you don't, or you may not have all of the answers just yet. So you complete the document to the best of your knowledge, and then you might come back to it in a few weeks or a few months' time and update it, because by then you will have figured out more things. You'll know more about the data that you're collecting and so forth. Your team may have changed. Somebody might have left, somebody might have joined. So you can always come back to this tool, and it is a requirement to include it in the appendix of your stage 2. It's also useful to, if you just want to print out a hard copy, to have a chat with your supervisor or something like that. So it can do a lot of things for you. The milestones, there's a link at the bottom of this page too, just with some general information about your milestones. I'm sure you've all seen that already. It just goes through stage 2 and confirmation in a bit more detail. We've kind of skirted around this, or we did sort of mention it briefly earlier, but this is an issue referred to as metadata. So kind of a slippery thing to try and define, but it is just trying to describe data. So it's data about data. It's just trying to give some context to the data so that it can be found and used into the future. So the images on this slide here, I believe this is actually another true story. I've heard that at one point an office at QUT was being cleaned out, and this box full of data tapes was found. So these are high capacity magnetic tape cartridges that are used to store data. So if you just found that box looking like the first image there, how would you know what to do with it? How would you know what's on it? How would you know what's on each of those tapes? Do you have to put in each tape one at a time? Even if you did that, you may not have the right software to read the data. So how do you know what's on those tapes? How do you know if they're important? How do you know if there's a legal requirement to retain them? So luckily there was also some metadata that was found with these tapes. So the other image at the bottom there is that folder, which provides some descriptive information about each tape, what the data is, where it came from, who created it, what kind of software was used to create it, dates, or version control. All of those things were recorded in that document, which means that data is still usable. So it is possible for someone who's never seen it before to know what's in that data collection and know how it could potentially be used again. So keeping this metadata is not only useful for you so that you can remember what you did. So, in 2 years' time, if you want to look back at some of the early data collection that you did, it might be helpful to know where it came from, when you collected it, what software you used, all of those things. But also, if you are able to share your data, so when you get to the end of your project and you're no longer publishing from that data, if you can share that data, you can also provide the metadata that goes with it to help other people make sense of what you've got. So they'll know what the data is, where it came from, when it was created, and so on. I guess an obvious example of is a README file. So I'm sure everybody's installed something at some point or put an app on their phone or something at some point and it came with a README file. That's metadata. That's giving you some information about the tool itself to help you make sense of that tool. Okay. So the different types of metadata, these are some examples of types, and there is a question in the resource log about metadata. Of course, we'd like you to put it in your own words. So rather than copy paste from the AIRS website, it would be nice for you to put it in your own words to demonstrate your understanding of these topics. And of course, too, the question relates to not only the metadata, but also how it relates to those principles of FAIR, F-A-I-R. We'll have a closer look at that in a moment, but a reminder that stands for findable, accessible, interoperable, and reusable. So when we're talking about these different types of metadata, or when you're writing about those types of metadata, your response should also illustrate how that the metadata makes the data findable or accessible or interoperable or reusable and so on. So other examples of metadata, well, they're all around us everywhere. So whether it's something you create yourself as in your EndNote library, so using labels to categorize information, your coding system, hashtags on Twitter, music genres in iTunes, Flickr aperture settings, grocery shop aisle signs, library subject headings, these are all types of metadata. So they're trying to give you some contextual information about other data. We've mentioned this, these principles. These are just some, well, they're principles, as I've just said, to give people some guidelines on how they can curate their data, particularly when it comes to sharing and reusing that data. So firstly, you want to make sure your data is findable. You need to save it somewhere, put it somewhere where other people know where to look and would be able to find it. It has to be accessible. So that means that it has to be readable by a human or by a computer. So that we need to know what format that data is, what kind of tool would be needed to use that data. So again, this comes back to the metadata. So that the accessibility just means that it is actually usable. So interoperable means that it may also be used by a computer and perhaps compared or combined with other data. So if you've got a data set and there are other data sets that are similar or comparable, being interoperable means that it could be combined into to create a larger data set. And reusable is again relates to the others throughout, in that the data that's saved has to be sufficiently described for humans and computers so that they can be replicated or combined in future research. So this relates back to the metadata to make sure the data meets all of these requirements. Let's have a look at an example of a data record, and we'll identify descriptive metadata, provenance metadata, technical and structural metadata, rights and access metadata. So let me just click on this link. So the next slide has a screenshot of this particular record, but I'd like to bring up the original because I noticed yesterday afternoon that there's a little bit of extra detail on the actual data record compared to what's in our PowerPoint slide. So we'll need to update our slide on that. The differences are slight, but they are there. So firstly, can you see anything here that talks about the who, what, why, when, and how this data was created? Perhaps I should provide a little bit more context. So what we're looking at the moment is a record in a tool at QUT called Research Data Finder. So Research Data Finder, among other things, is a place where authors can upload their data sets. Part of their process is to create these records that describe the data set. So these records are metadata. So here we should be able to find the who, what, when, where, and why for the data. So can you see anything there about the who? I mean, we can see here under connections that this particular data set was created by these two researchers, and we could even click on those links to see what other data sets they've created. We've got some data about the dates. So when was the data collected? So it was collected over a 2 or 3 year period. We can see when this particular record was created and when it was last modified. And we can see that it has an open access status. So some of you may have come across Creative Commons licenses already. So this is a way of sharing either publications or data sets, although a data set is a form of publication. So you can share it with other people, but you can still impose some conditions on that, and you of course still retain your copyright of that. So there are different levels of copyright license that you can use. We've got another slide coming up later, so I'm probably jumping ahead of things here, but I might wait till that slide comes up. But you can allow people to do different levels of things with your data. Okay, so we've got other information here, some geographical information about where the data was collected. There's an abstract of what it's about. There's some information there about the tools that we use to collect the data. There's a link to a research output related to the data. So this is all metadata describing that data set. So if I switch back to the presentation, and we can have a look at highlighting some of that information. So the who, what, why, when, and how, that's pretty well captured in that main section of the page there. Specifically though, if we look at provenance metadata, there is some text in there that actually talks specifically about the tools, the version tracking and transformations of that data to help people make sense of the data set. We've got some technical and structural metadata, again, talking about how that data is organized, what kind of data it is, and how it all relates to each other. And as I mentioned, there's rights and access. So who can use it and what are they allowed to do with it? What restrictions apply and so on. So hopefully that gives you an example of how metadata is used in practice. This is another element that you'll need to respond to in the AIRS resource log. So identifying the minimum legal requirement for data retention. So it does relate to what kind of data you're collecting and whether or not there's a patent involved, whether or not you're involved in a clinical trial, whether or not there's some significant aspect to your research outcomes. So keep in mind that these are minimum retention periods. So it doesn't mean you have to destroy your data after 5 years. It just means that you are required to keep it for at least 5 years. And if your research sets the world on fire and it becomes a significant discovery, well, then your data can be retained permanently. There's no reason why it has to go anywhere. So in identifying your required retention period, we're talking about a minimum retention period, not a maximum. Okay, so back to data storage. The QUT IT specialists or IT specialists everywhere talk about this 3-2-1 rule when it comes to storing data. So basically that means you have 3 copies of your data stored in 2 locations. One of those locations must be offsite. So that gives you maximum protection if disaster should befall you. So if your laptop fails and it doesn't start, you can still go back to your backup copy and pick up where you left off, or at least pick up where you last updated your backup. So at QUT, we have some cloud storage that's available that is recommended and is safe for backups. The RDSS, the Research Data Storage Service, is the preferred cloud service. And on the next slide, I'll talk a little bit more about some of the other options that are available. But we've also got just a little scenario on this slide to explain how it works. So if there's an example here of a researcher, Tracy, who's using data from Queensland Transport. So the data comes to her in a CSV file that's on an encrypted USB. The raw data must be kept on QUT network storage for security, processing, and analyzing purposes. So it's confidential information. It's not for sharing at this point, other than back with the industry partner, Queensland Transport. So the data arrives on an encrypted USB. So as soon as possible, it should be put into the recommended location. So a master copy of the data would be saved into the RDSS raw data folder. So this is the ultimate backup copy, the raw data that doesn't ever get used. A working copy is created by just copying that master file, and this is the one that is actually processed and analyzed. So that might be moved into a different folder that can still be kept on the RDSS server. RDSS is a cloud service, so it is accessible from multiple locations, but it is a QUT service that keeps your data safe and secure. The other advantage is for coming back to that 3-2-1 rule. RDSS research data is backed up to removable tapes which are duplicated and housed in 2 security compliant, geographically dispersed data centers. So that complies with that 3-2-1 rule. In this case, the IT staff are actually creating that off-site storage option for you. Okay. So just a quick summary of some of the different options that are available. And the first thing I'll do is draw your attention to that box on the right. A reminder, things like external hard drives, thumb drives, commercial cloud drives like OneDrive, Google Drive, Dropbox, and so on, portable storage devices, they're not recommended for long-term storage of research data. So, of course, if you're out in the field collecting data, you need some way of getting that data home again. So you probably do need to use an external drive, but you need to be aware of that risk. And as soon as possible, move it onto a secure system like the RDSS. So this table just illustrates 4 different services. There's the RDSS, there's QUT OneDrive. There's 2 other cloud services that can be used and are recommended for different purposes. So something like ARNet's Cloud Store, that is suitable for research data. However, it's not recommended as a location for storing your master copy. So there may be some legal implications about storing the master copy there. But it is an Australian cloud service, so it does comply with all of those other issues. So size, sensitive data, sharing with QUT, sharing with non-QUT people, remote access to data, and so on. QCIF is another service that has similar functionality, except that it's not recommended for sensitive data. So sensitive data means confidential, such as human data or data that can't be shared at that point in time. So I've mentioned before publishing the data. So this slide has an indication of the different kinds of Creative Commons licenses that are available to use. So there are essentially these 4 different characteristics that you can combine as required. So the very basic one is the BY, which just means that you can share you're happy to share your data, but you're not allowing anyone to manipulate that data or combine it with anything else or to profit from it. And if they are going to refer to it, they must cite the original work. So that's the base level Creative Commons. And then you can have different permutations of those characteristics. So non-commercial, no derivative, and share alike. Share alike just means that if you allow someone to edit your data, one of your stipulations is that they must then share their manipulated data set under the same license that you've used. So it's just a way of paying forward reuse of the data, just to make sure that anyone who's done something with that data also shares it. On the left-hand side is some links to some services where you can store that data. And the link down the bottom is the Research Data Finder, which we had a brief look at a moment ago when we were looking at the examples of metadata. But there are some free online repositories that you may or may not need to use, things like Figshare and Dryad. They're free open access repositories. There are some others that are specific to particular disciplines, so you might need to talk to your supervisor about whether you need to use one of those, or whether or not QUT data, research data finder would be sufficient. The other thing too, just while we're here, it's not on the slide, but when you're publishing, quite often journal publishers will mandate that you must share your data as well. So if one of the conditions of publishing is that your data is shared. So something like Research Data Finder is a way of you uploading your data and making it accessible, and that will be compliant with the journal. Here we are back at the diagram we looked at the beginning, the research data lifecycle. So along the way, we've discussed issues relating to each of these points. So planning the research, we talked about the SRMO, the SAGE research methods online. We talked about some of the data sets that are available, or the potential for obtaining data sets if we don't already have access. In other words, you can perhaps reuse data. We talked about collecting data. So you were thinking about your own research data, how you'll collect it and what form that will take. We talked about sharing the data, preserving the data, reusing the data. So what data storage requirements are recommended? What's the importance of metadata? The use of Research Data Finder as an example of a registry and a repository of data. And we talked about adding license information such as a Creative Commons license to your data set. Actually, one thing I didn't mention back on that slide is that your data set is a form of publication. So if you share your data, that is actually a citable document. So that can all count towards your publishing track record, and you can collect citations, and you can that can go on your CV. So all of that is still useful for your profile, your publishing profile, your academic profile, your researcher profile. So the data is a form of publishing. But of course, publishing also are the research outputs. So once you've analysed your data and drawn your conclusions, then you're going to be publishing. And when your data is, when you've finished publishing from your data, that might be the point where you think, well, okay, I'm done now. I'm happy to let someone else have a look, and maybe they can make use of this data as well. So in order to do that, you need to make sure that the data is preserved and described using metadata, that it's findable in a suitable repository, and that it is able to be used by other researchers. So whether they use that data as is, or whether they combine it with some other data set to create a bigger data set, those are all possibilities that are available. And of course, that licensing is an option for you as well. So using a Creative Commons license just makes it clear what you are happy for other researchers to do with your data. All right, so just like the end of AIRS 2, there's going to be a little bit of homework being set for you before you go on to AIRS 4. So AIRS Module 4 is about publishing and publishing metrics. So what we'd like you to do before coming to the AIRS 4 module workshop is to think about a journal that you might consider publishing in at some stage. So publishing might not be at the front of your mind at the moment, but it is something to be aware of. At some point you will be publishing. So think about which journal might be suitable for you to publish in. Go to that journal's website, have a look at the journal's aims and scope. So what is it that the journal, how does the journal describe itself and what its purpose is, and what is it interested in publishing? Does that align with your research interests? While you're there, have a look at the author guidelines. So all of the journals will provide some guidelines on how manuscripts need to be formatted. So it can be mundane stuff like font size and double spacing and so on, but there's also some other requirements perhaps about tables and images, referencing styles. There's a whole suite of formatting requirements that they may require. How do you submit your manuscript? Those things are important. The other thing we'd like you to do, if you haven't done so already, is to create your ORCID. So if you haven't come across ORCID before, it is an acronym, and I don't know if Cameron remembers it off the top of his head, but I can't remember exactly what ORCID stands for. But the important part is that it's a unique identifier for you. It's like a 12-digit character, a 12-digit code that you can use as your unique identifier. So whenever you publish an article, you can include your ORCID ID with your name, so that if there are other authors in the world with the same name as you, people know which author it is, and it also then gets tracked in the databases and it's allocated to your particular publishing history. So it's free to register. It is also a requirement for QUT. QUT systems use the ORCID ID to track publications through some of our internal systems. And it just takes a moment. Thanks, the Open Researcher and Contributor Identifier. So it only takes a few minutes, and it is something you can edit as often as required. So if you get a new job or something like that, you can update that as required. So as I mentioned already, AIRS4 will be about publishing for the most part. So where do you publish, and how do you evaluate the impact of your publishing? So there are some different ways of assessing the impact of your research. So different types of metrics to calculate that. And that brings us to the last slide for today's presentation. The resource log doesn't have a word limit. So I beg your pardon, we do give you a recommended word limit, but it's not part of the assessment. So what we'd like you to do is to be concise. We've tried to structure the questions so that they don't require long answers. You should be able to get a meaningful response within a small amount of text. So we don't need long essays. We don't need to be referenced. You can if you want to, but it's not required, it's not assessed. I don't think I have a copy of the assessment with me, but let me bring that up on the screen and we can perhaps have a look at that. So, okay, so while I'm here too, let me just quickly remind you too about the criteria sheet. This is the criteria sheet that we use to assess your resource log. It's what the librarians use to grade your paper, but it's also there for you to know what the expectations are in terms of how to respond to the questions. But if we have a look at the log itself, here we go. I'll just drag that across. So we do say that you should be able to respond to all the questions in less than 2,000 words. So, but it is just a guide. We're not going to penalise anyone who goes over that word limit, and there's no minimum word count either. But we do try to encourage you to be concise. You don't need a lot of words to respond to the questions. You should be able to get a meaningful answer fairly concisely. So I hope that was helpful to everybody looking at your research data, different ways of managing it, storing it, protecting it. It is a valuable asset, so you do want to do whatever you can to keep it safe and protected, so that if a disaster happens, that you don't lose everything. Maybe you'll lose a day's work or something like that, but having a routine of backing up your data will make sure that you minimize that loss. Okay, if you do have any questions after the session ends, remember you can also contact your liaison librarian. So if you're not sure who your liaison librarian is, there's a link on the library's homepage down the bottom that says contact us, and you'll find a list of liaison librarians. Just find the person for your particular discipline, and you're welcome to get in touch and ask questions of them. And if there are no more questions now, we might call it a day. So thank you, everybody, and good luck with your research.